range multiplier and a fair range multiplier, and we have a lookback period. We define that lookback period as 20 bars here, for example, and then we define the profit targets, and we define where the stop is. The stop is typically at a local minima or maxima, and really
spec structure, bar contacts, look back window, n8n contacts, and enter logic, and then the local swing-based risk management, and then real challenges that getting translated into Python, optimized consistently, and deployed without introducing drift. So when you move a strategy from Pine into Python, do you already have a standard structure for representing inputs, the signal condition stops and targets, or is each strategy currently implemented more or less from scratch? And then for optimization, are you mainly tuning numeric thresholds like look back, multiplier center, percent constraint, target stop, target stop?
Yeah, that's more or less correct. So we have the structure already in place through Python. Some of them might be too complex. I'm sorry, not through Python, through PineScript. Some of them might be too complex for PineScript. And we might have to eventually come up with a solution, but I'm not going to worry about that right now. But it does start off with PineScript. The structure is there based on the principles of the strategy. The next stage after converting into Python is the optimization. So we would have to fine-tune the inputs that are necessary for it. So, and it's really a calibration measure. So, for example, this is the S&P. We have inputs over here for, for a range multiplier, which is 1.2. It could be for other instruments, maybe crypto or metals or other commodities where 1.2 might not be the appropriate input. So it would have to be optimized for that based on backtests. We would also have to forward test it to some degree for deploying it. But we have the basic framework here with the inputs, and the optimization would solve for the rest. As far as targets, it's really based on an average bar range. Stops are defined, stops are predefined, targets are also predefined based on average bar range.
And then when you say deploy, do you want the live Python strategy to operate off the exact same bar close event model as the Pine logic with that CDG layer acting as the only execution adapter?
I believe I do. But once it's deployed, it should be following the same logic of the way it's coded in Python, and the Python code should reflect the logic of PineScript. The only variables to decide are the inputs, which should be that should be addressed through optimization and through the backwards.
And then when the strategy gets moved into Python, are the inputs already represented in a standard way so they can be swept?
I experiment with the inputs before handing it over for translation to Python, but of course there's always room for improvement. So when I hand it over, there has to be a certain threshold for win rate, profit factor. I wouldn't just hand it over if the metrics are completely ridiculous. But one thing I need to keep in mind is TradingView does not have very reliable backtesting. The further back you go, the more unstable it can get. So that's one of the drawbacks of that. But I'll typically refer to first principles. So, for example, a range multiplier of 25 across 20 bars, that's not a spike, right? It can't be a spike because it's only going up half the range. So that on space would not, that just would not be valid to hand over for optimization.
Okay. So the training view is really the hypothesis and visualization, but not the final source, and that means that the final source of truth in the Python backtest environment needs to become more the canonical validation layer, because that's where you actually control the data assumptions, and the calibration workflow and the consistency of the results.
Precisely.
Okay.
Training view is just a quick and easy hypothesis. Get the process started.
So define training is necessary to define and visually confirm that pattern in its intended chart context, and the Python side's not meant to replace just the pattern definition. So Python's more the implementation, calibration, testing side once the setup's been specified. So
good. And now that you brought up context, there are a lot of contextual factors involved aside from what we're seeing here. So, for example,